The next section that we're going to be looking at is 5.2, and that's solving and graphing linear equations using multiplication and division. Alright, here's our first example. We want to solve the inequality x divided by 3 is less than 7. Check and graph the solution. So these are very similar to solving one-step equations. So if we've got x divided by 7 x divided by 3 less than 7, we look at the side of the variable. It's being divided by 3, so we want to undo that. So we need to multiply this side by 3, and what you do to one side you have to do to the other to keep it proportional. So when you do this on the left side, we then have x by itself, and then on the right side 7 times 3 is 21. So x needs to be less than 21. Well, let's check this answer first. Let's pick a number less than 21. Let's say x equals 18. Let's plug it in and see if we get a true solution. If we get a true solution, then the answer checks out. Well, 18 divided by 3 is 6. Is 6 less than 7? Yes, it is. So our solution checks out. Now let's graph this on a number line. I'm just going to put 21 in the middle, 22, and 20 on the side. When we have the less than symbol, that means we have an open dot. So there'll be an open dot at 21 and anything less than that. So we want to shade to include anything less than 21. Alright, here is the second example. We have a decimal in here. Solve 1.5 times c is greater than or equal to 7. We want to graph the solution. So we've got 1.5c greater than or equal to 7. Well, again, this is going to be like solving a one-step equation. So look at the side of the variable and look what's being done to it. We have c being multiplied by 1.5. Opposite of multiplying by 1.5 is to divide by 1.5. So we will do that on both sides. After doing that, we've got c by itself on the left side, and greater than or equal to, when you do 7 divided by 1.5, you get 4.6 repeating, and if you were to write that as a mixed number, that's 4 2/3. Now if we put this on a number line, I am going to put 4 in the middle, I'm going to put 5 over here, 3 over here. Now we want to break this into thirds, so I'm going to look at the distance between 4 and 5 and break it into approximately 3 equal spaces. I'll do that in between 3 and 4 as well. And if we want to do 4 2/3, we go to 4, and then we go 2/3 of the way. And then since it's an equal to symbol in there, we're going to do a closed dot. So we're going to fill that in. And we want numbers greater than that, so we are going to shade to the right. So anything to the right will be a solution. Okay, so when you're working with solving inequalities and you're trying to get the variable by itself, most things are very similar to solving an equation. But there's something that you need to remember. When you're dividing or multiplying both sides of an inequality by a negative number, you must reverse or flip the direction of the inequality sign to produce a correct solution. We're going to look at 2 examples following here to demonstrate this. Right, here we are in the third example. We want to look at this inequality. X divided by -4 is greater than 12, so we want to undo what's happening to the variable. So it's being divided by -4. The opposite of that is to multiply both sides by -4. And if you look at what happens to both sides of the inequality, over here multiply by a -4, and on the left side multiply by a -4. If you have to multiply or divide both sides by a negative number in an inequality, you need to change the direction of the inequality sign to make it a true solution. So I'm going to flip that. On the left side, when you multiply by -4, you get x by itself. On the right side, you get -48. Let's check this answer. So if we pick an answer that is less than -48, let's say x is -60. That's less than -48. Let's plug that back into the original equation and see if it works. If it works, then we have a solution. So negative 60 divided by negative 4, is that greater than 12? Well, negative divided by negative is positive. 60 divided by 4 is 15. Is 15 greater than 12? Well, yes. Then we've got a solution. So if we put this on a number line, negative 48, negative 49, negative 47. We got an open dot because it's a greater than symbol. And we want to shade to the left for our solutions because we want numbers that are less than negative 48. Alright, in this fourth and final example, we've got the inequality negative 3 times v is greater than or equal to 33. So we want to get the v by itself. It's being multiplied by negative 3. So we undo that. We're going to divide both sides by a negative number. And if we do that, I'm looking at what we do on both sides. On the left, we divide by a negative 3. On the right, we divide by a negative 3. And if we do that to both sides, we have to flip the direction of the inequality sign to make it a true solution. After we do that, on the left side, we get v by itself and positive, which is what we want. On the right side, we've got 33 divided by negative 3, which gives us a negative 11. We want to find a number that is less than or equal to negative 11. Let's say v equals negative 20. Let's plug that in and see if into the original equation, see if that works, and if it does, we have a solution. So negative 3 times negative 20, is that greater than or equal to 33? If it is, then our answer or solution works. Well, negative 3 times negative 20 is a positive 60. Is positive 60 greater than or equal to positive 33? Well, yes, it is, so our answer checks out. If we are to graph this on a number line, we've got negative 10, negative 11, negative 9, and negative 12. So we want a closed dot at negative 11 because it includes the equal sign, and we want a shade to include everything less than that.